Hello, good morning everyone. I hope you are doing good. So today we are going to continue our discussion under database engineering. So before going to the new concepts, let's have a recap of whatever we discussed so far. So I'm expecting now the responses from your side. So what we studied so far?
Introduction to the database system.
Okay, what next?
Definition about database management systems. Then commercial database systems, open source database systems.
Okay, next.
Database applications.
Okay, database applications. What next?
Database system versus
Schemas.
file system.
Yes. What?
Drawbacks of file processing system.
Correct. What next?
Data abstraction.
Okay, data abstraction. Next,
Database system.
data.
Relationship between levels of abstraction.
Yes, correct.
Schemas and instance.
Schemas and instances. Okay.
Physical data
Data
independence.
models.
Data models, right?
ER model.
ER model. Okay.
Relational model.
Database languages.
Database languages, right?
Integrity constraints.
Integrity constraints. Okay.
Data manipulation language.
Yes.
Data definition language.
Yes.
Database users.
Database users. Yes.
Storage
Data
manager.
system architecture.
Database system architecture, right?
Database
Database
administrator.
Database administrator, duties of database administrator. Okay, anything remain?
two-tier architect, two-tier and
Query
three-tier
Component.
processor. 2-tier, 3-tier.
Yes, two-tier and three-tier architectures and various components of database system architecture that include storage manager and query processor, the two major functional components. And we have also gone through the various subcomponents of these components. So overall, how our database management system works that we know, right? So this was included as the first part of unit number 1. So we had a discussion about the overall database management systems and very basic concepts or fundamental concepts in database management system. So in this part 2 of unit number 1, actually we are going to discuss about ER model, entity relationship model in detail. But prior to going for ER model, we are just having an overview of database design process. So what are the steps included in building any database application? In fact, many of these steps actually you have gone through the software engineering and you know whatever is the methodology or the steps those need to be followed while building any software project. database is also one of the software projects. So we are supposed to follow similar kinds of steps, those you have learned in software engineering. But still, we are going to list out the different steps or phases in database design process. Those are more relevant with building a database application. So let's begin with the step number 1. And the step number 1 says that first of all, we should come up with a high level data model. So what we mean by high level data model? Actually, as you might be knowing that whenever we go for any kind of software application, the very first step needs to collect the data, right? So whichever may be the enterprise, to begin with, we need to gather the information about the enterprise, or we need to collect the information related to the enterprise for which we would like to build the application. So here also we need to collect the data, and also we need to analyze that data, and we should come up with a system requirement specification, popularly known as SRS, system requirement specification, right? So we need to think of how our database system can be structured to fulfill whatever are the requirements those we have collected in the initial phase of data collection, right? So in the initial phase of database design, we need to characterize fully the data needs. We need to analyze the perspectives of the database users, what they want. The database designers need to interact extensively with the domain experts, the users who are going to use that system, right? And ultimately, after having the discussions with the users who are going to use that application, right? And after collecting the required data, the final outcome of this first step is the specification, system requirement specification, or the SRS, right? So once we are having this high level requirement of the application, then the next step to be followed is the conceptual database design. So what we are going to do under this step? Under this conceptual database design, first of all, we need to think of what kind of data model we are going to use to represent our data that we have collected, right? So say for example, we have seen many different kinds of data models, right? So under conceptual database design, we need to understand, we need to select appropriate data model that we are going to make use of. So in our approach, what we are going to follow is, we'll be picking up first the data model, that is the ER model. So in conceptual database design, first of all, we are going to make use of ER model, right, to graphically represent the requirements those we have collected in step number 1, and then we'll be making use of the relational model, right? So we are going to select these models. So in our case, we are going to make use of ER model and relational model. But in fact, we are having several data models, and we had a discussion about those models. So in this stage, based on whatever is the requirement of the enterprise, we need to come up with the conceptual database design, and for that, very first step is to select the appropriate data model. Then whatever data model that we have selected, we need to translate our requirements into the conceptual database so that we can effectively model our requirements with respect to that particular database design or that particular data model. For example, if I have collected, suppose I want to build the university database. So in the very first step, I need to collect the information related to the university, whatever are the requirements. I'll be coming up with
Yes.
the system requirement specification. And after
Yes.
that, I'll be picking up the data model. So let us assume that we are picking up first the ER model. So what this ER model will do? ER model will try to understand out of the requirements what are the entities, what are the relationships, and how I can model that in the form of a graphical representation. So that can be done in step number 2. Yes, is there any doubt? Is there any doubt? May I proceed? Am I audible?
Yes, ma'am.
Fine. So in this step, we are coming up with a data model, selection of a data model, say for example ER model that will be using to pictorially or graphically represent our requirements. Then we are going to translate those requirements, right, in another conceptual database model, and that is the relational model. So we'll be forming the relational schemas, right? Then we'll be having the detailed overview of enterprise comprising the required data, data types, constraints, and we'll try to validate whether our conceptual database design is appropriate, or we may have some kinds of iterations to come up with a good conceptual database design, right? So in this second step, we are picking up the data model to be used, and whatever data requirements those we have collected from the enterprise, will try to translate those requirements in terms of the model that we have selected. And once again, we'll be having the entire overview of the enterprise, right? So we'll check whether all the requirements are being satisfied. We'll specify what kinds of data types are required to store that data in the respective data model, what kinds of constraints need to be imposed. So we are going to have the detailed design, conceptual design based on all those concepts. In the third step, what we are going to do next is the specification of functional requirements. So now we are ready with our conceptual database design. So if I am using a relational data model, then I'll be having, right, the relational schema. I'll be having the structure, right? Pictorial structure may be drawn, depicting what kinds of attributes to be grouped together to form one table, right? What kinds of relationships I'll be having in different sets of attributes. Everything is being thought of in this conceptual database design. And after having this conceptual database design, I'm ready with my data requirements and the initial design. So I'll be listing out now the functional requirements. So what kinds of operations need to be performed on whatever data I am having or whatever data I am representing. So functional requirements. So whatever we have collected the information, we need to come up with the functional requirements. What we mean by that? Whatever are the needs of the users. Say for example, we should list out the functional requirements such as the operations to be performed on the data. So we need to input the information, That is one kind of operation. We need to edit or modify whatever is the existing data. That is one more operation. We may need to delete the data. That might be another operation. We need to search the data. We need to retrieve the data depending on whatever is the requirement. So all those are the functional requirements. Those kinds of operations actually need to be performed on the database. So we need to list out all such operations, and we need to think of whether our design is suitable to provide such kinds of functionalities to the user. So that is what the step number 3, specification of functional requirements. The kinds of operations, those need to be performed. These operations need to be collected. These operations need to be listed out, and we need to think of, we need to check whether our database design is useful or appropriate to provide all such kinds of functional requirements, to satisfy all such kinds of functional requirements. The next step, step number 4, is actually the choice of database management system. So here actually we are making the practical decision now. Which kind of database management system needs to be utilized for implementation, actual implementation. So in step number 1, 2 and 3, we were thinking of the design, overall design with various perspectives of the database system. And in step number 4, if we really would like to implement now this database management system, what kind of database management system I'll be making use of? Maybe it is a relational database system like Oracle, maybe it is MySQL, maybe it is SQL Server, maybe it is PostgreSQL, whatever it may be. So we need to find out, or we need to identify the appropriate database management system to be used. In step number 5, after selecting the database management system to be used, practically now we are going to implement it. So we are coming up with now the logical database design. So actually whatever is the relational model that we have created in step number 2, that relational data model or the relational schema that we have is now being actually implemented. So we are going to build the structure. We are going to create the tables. We are going to specify the constraints practically. So this is the logical database design. So building actually our database model, right, using some kind of database management system. So let us assume that we have selected Oracle to be used as the database management system. So we'll be using now the Oracle, and we are actually now creating the tables, creating the logical schema. We are imposing the constraints, integrity constraints. We are mentioning now actually practically what kind of data type or domain to be associated with the attribute and so on. So this is how in step number 5 we are going to have a logical database design. Next, we will think of the physical database design. So what we mean by that? So typically the database administrator is looking after the physical database design. So we need to mention here what kinds of storage structures we are going to make use of, what kind of file organization system that we'll be making use of, what kinds of indices we are going to make use of. So all these kinds of decisions are being taken at this level, that is physical database design. Finally, after having our structure ready with us practically, we have implemented the things. logical database design is ready. We have thought of what kinds of data structures to be used, what kind of file organization mechanism to be used. Everything is ready now. So in step number 7, we are actually implementing our database system, and rest of the things after implementation, as we know in software engineering also you might have studied. Finally, we need to test the system, we need to evaluate the system with the several test cases, and once the system is correct, then we'll deploy that system. Okay, so most essential thing is we need to carry out this design process effectively before actually developing the application programs. Application programs are the front ends. So see, whenever we build any database application, we are having two important designs. The first is the backend database design and the front end design. In backend design, whatever steps we have listed so far, those are related with the backend database design process, right? In the front end, we are supposed to build the application forms, the GUIs, the interfaces. Those we are going to provide to the users. So through those forms, through that front end design, actually my users are going to interact with my database system. So I have designed my database system, this whatever we have discussed, that relates with the backend process, the backend database design. Okay, and whenever I'm talking about a full-fledged database application, we also need to think of the front end. So front end comprises of making use of some kinds of tools. Those will help me to prepare the forms. And now whatever forms I'm going to prepare, I will be having the connection between the front end components and the back end components, right? And this is how the entire application program I'm going to build, database application I'm going to build. So before actually starting the front end design, we should think of this back end process, right? And once the back end database design is ready with us, we go for actually developing the application program, right? So this is the process that we need to follow for any kind of database application, building any kind of database application. I hope you must have understood the steps or the phases in the design process. If you have any doubts, please let me know. Is there any doubt?
Ma'am, logical database design and physical database design, there is confusion.
Okay, so let me once again explain you what we mean by logical database design and what we mean by physical database design. So if we are talking about the university schema, okay, if we are talking about university schema, in step number 2, whenever we talked about selecting a data model, right, and depicting or translating the requirements into the conceptual database, we in step number 2, we were considering, like, say for example, we have seen that we had one instructor table, right? So relational model deals with tables that we know. So we should come up with one instructor table, we should come up with the student table, and as we know, we are having some relationship between the student table and the instructor table. So we have seen one such relationship, that is advisor, right? So whatever I'm drawing right now, this is the ER model. Associated with this ER model, I'll come up with the relational model having different kinds of tables. So I'll be having instruction table, I'll be having the student table. I'll be having another one, that is the advisor table also, right? So whenever I'm saying these are the tables, meaning I'm grouping the attributes those I require to store in individual table. So right now this is on paper, right? So in conceptual database design, we are not actually implementing anything. We are just designing our system, maybe in the form of diagrammatic representation or maybe in the form of the various tables, right? But still we have not yet implemented anything. We are just thinking of the data types. We may think of the constraints to be used to validate our data, right? So everything is being taken care of under step number 2. So once we are having such kind of conceptual design with us, under logical database design, what actually we are going to do is we are going to implement it in relational database model that we have selected. So let us assume that we have selected database management system, that is Oracle. So in logical database design, what we are going to do? Suppose we are going to make use of Oracle as my database management system. So in logical database design, I'll be referring to the relational schema that I have designed in step number 2. And actually now I'm going to create those tables. I'll be building that logical database design now. So I'll make use of create table statement to create instructor table. I'll make use of create table statement, right? Say for example, to create student table, to create advisor table, and many other tables, those are required. So while creating the table, I'll be making use of whatever are the attributes those we have listed in our relational schema, relational conceptual schema. So I'll be making use of, I'll be referring to the conceptual database design, and I'll be actually creating my schema. I'll be actually creating my structure of the database where I'm going to store practically the data. So once now I have created the entire model, database design, logical database design, in the next step I need to think of the physical database design. So what is the difference in logical database design and physical database design? In logical database design, I have created the tables, I have defined only the data types. But whoever is building this logical database design need not think of the physical database design. How actually physical data means, physical level means how actually the data is being stored. What data is being stored, that I have mentioned in logical database design by creating the tables, that this data I would like to store and in this form. But how it is being stored, that has been specified in physical database design. So as I mentioned, the database administrators are actually taking care of this physical database design. So we need to specify the file organization here. So what we mean by file organization? If I'm creating one table in logical database design, okay, so I'm having various attributes. Say for example, in my instructor table, I'm having ID of type character. Say for example, I'm having name of the instructor, once again of type character, right? Salary of type number, and so on. So these are the attributes those I am having in a particular table. Correct? Now in physical database design, I'll be thinking of the organization of that data. What kind of file organization will be using? So whether it is a fixed record size or whether I need to make use of variable record size, something like that. We are going to focus upon this in one of the units, right? I think it is unit number 4. So we are going to focus upon these details in unit number 4, right? But just remember that in step number 6, that is physical database design, we are thinking of how actually the data is being stored in my storage device. So what kinds of data structures to be used, what kind of storage mechanism to be used, what kind of records, whether the records are being stored as a fixed width records or variable width records, right? All such kinds of decisions, what kind of index structure I need to use, all such kinds of decisions are being made in this step number 6, that is physical database design. In logical database design, we are creating the tables, we are putting the constraints, that's all. In physical database design, we go one step ahead, how actually that is implemented, how actually at the physical level we are going to store the data, right? I hope I have answered your question.
Yes, ma'am. Thank you.
So we are going to start now with part 2 of unit 1, wherein we are going to discuss in detail entity relationship model. So as I stated earlier, in our design process, whenever we talked about the conceptual design, we are going to first make use of this ER model, right, to come up with the graphical or pictorial view of our entire database system after collecting the requirements from the enterprise, right? In fact, we had a little discussion about entity relationship model in our previous session. So in this part 2, we are going to discuss all the basic concepts related to ER model. Then we are going to come up with a real world application and actually its solution in terms of ER model. And after that, I'll be providing you with several real world problem statements for which you are supposed to come up with your own ER models, your own ER diagrams, right? And we'll be having the discussion with respect to your solutions. And if you face any problem in understanding the concepts, we are going to resolve those problems. So this is the very first and essential step in having a good database design, right? So let us begin our discussion. What we are going to study under ER model. There are several concepts, those we are going to discuss first, and then we'll go for ER diagrams. So we are going to talk about entity sets and types. We are going to talk about attributes and its types. We are going to talk about relationship sets and types of relationships. Then we'll be focusing upon the constraints. Under that, we are going to discuss the mapping cardinalities, participation constraints. We'll be discussing about the keys, various kinds of keys, and then we actually go for drawing the ER diagrams. Under that, we'll be talking about few design issues. We will focus upon extended ER features like specialization, generalization, and aggregation. And after discussing all those concepts, we are going to build our own ER models for the given problem statement. So we are coming up with the designing the ER model for any kind of real world problem that is being provided. So ultimately, the outcome of this discussion would be designing ER diagram, designing ER model for a given problem statement, right? And in our laboratory sessions also, we'll be having this as the very first assignment, right? So every batch will be provided with one problem statement and they are supposed to come up with the appropriate ER model. Okay, so let's begin with entity sets. So what is entity set? We had a discussion before. So in fact, a database is modeled with two important concepts. We are making use of the collection of entities and also we are describing the relationships among the entities. So what is an entity? An entity is an object that exists and that can be distinguished from other objects. So we may think that entity is a thing that can be distinguished from another thing, right? So few of the examples of the entity. A person is entity, a student can be described as entity, instructor can be described as entity, right? So all those are the objects. Those can be distinguished from one another. One person can be distinguished from the other person. One student can be distinguished from the other student, and so on. So entity is a thing or an object that exists and it is distinguishable from other objects. Now, if we want to describe any entity, we need to make use of attributes. Attributes, those are actually describing the entities. These are the properties of any entity. For example, if I want to describe people, I may use name of the person, I may use address of the person. So these are the properties of that person. If I want to describe instructor, which is my entity, how I am going to describe that instructor? I'll be making use of the attributes. And what are those attributes? ID, name of the instructor, salary of the instructor are the attributes. Those are describing the instructor, right? So by making use of these attributes, it is possible for me to distinguish two instructors, right? So two instructors will have different ID. Two instructors will have different name. So by making use of those attributes, it is possible for me to distinguish one entity that is instructor from other entity that is another instructor, right? So every entity is being described by making use of attributes. And what is entity set now? If I collect several entities together of same type, those are having same properties, then we say that it is an entity set. Say for example, if I'm talking about instructors, let us assume that there is one instructor having name A and another instructor say having name B. Right? I am having one instructor with name A, I am having another instructor with name B, and so on. I am having several such instructors. So if I say all these are the instructors, meaning they are sharing the same properties. They are having the same attributes. So every instructor is having ID, every instructor is having name, every instructor is having salary. So all these instructors are sharing the same properties, right? But the values those are associated with these properties or attributes are different for every instructor, right? So if I collect all such instructors together, then I'll say that this is my entity set. So entity set is the set of entities having the same type, and those entities share the same properties. Okay? I hope I am clear with the concept. If you have any doubts, please let me know. Any doubts so far? May I proceed? May I proceed?
Yes, ma'am.
Yes, ma'am.
So we are having here few examples of entity sets. So as I mentioned, instructor is entity set with two attributes here. We have depicted only two attributes, instructor ID and instructor name. So this one is one entity. This is another entity. This is one more entity. So collection of all those entities is the entity set. If I look at the entity set student, this entity set is also described by the attributes, right? And I'm having individual students, right? Those individual students are having the same attributes but different values. So whatever are the values, those describe actually that particular student, that particular individual, right? So if I'm having collection of students, I'll say that it is student entity set. Collection of instructors, it is instructor entity set. Okay, now let us go to attributes and types of attributes. So as I mentioned earlier, an entity is represented by set of attributes, and those are actually describing that entities. So attributes are the descriptive properties. Those are possessed by all the members of a particular entity set, right? Now, let's see the example. Instructor is having attribute ID, name, street, city, salary, maybe. Course is the entity set, and it may have the attributes like course ID, title, credits, and so on, right? Now, associated with every attribute, we are having a domain. So what we mean by a domain? It is the set of permitted values for each attribute. I'll repeat. Domain is the set of permitted values for each attribute. What I mean by that? Every attribute, say for example ID, every attribute is associated with some domain. So domain you may think of like a data type. So I may specify while describing my table, or rather whenever I describe my entity set or the relationship set, every attribute should be associated with some type, some domain. So ID may be of character type. So the domain associated is character. Or salary may be a number, right? So having some digits into that. So depending on whatever is the specification for that number, it is possible for me to find out the set of permitted values for that attribute. Am I correct? Say for example, if I am having one attribute, say ID is the attribute and the type is number or integer, right? And I am saying that this number is a 2-digit number, integer number, and it is 2-digit number. Then what is the set of permitted values? What is the set of permitted values? 2-digit number. Yes. What are the permitted values? If it is a 2-digit number, integer, I may have value associated like from 0 to 99, because it is a 2-digit number. So whatever is the domain associated with the attribute, this domain actually is telling us what is the set of permitted values for that attribute. So beyond that, any value is not allowed for that particular attribute. So that is what we mean by domain. Okay. In the next session, we are going to focus upon the types of the attributes. Several different types of the attributes we may have, right? So what are those types of attributes we are going to talk about in the next session? I'll be posting the link for the quiz. So you are supposed to answer the quiz. Okay. So we are going to conclude the session for today. If you have any doubts, please let me